For today's lesson, we're working on still creating equations to solve problems, but now we're going to focus in on perimeter and area. Okay, so because this deals with perimeter and area, we're going to review a little bit with that and what that is, and then we're going to relate it to the problems that we've been working with. Okay, so remember, perimeter is a distance, and it's literally the distance around something. Okay, so like if you were working in a real world type of situation, it would be like if you're putting a fence around a yard, you would have to find the perimeter, the distance around the part that you're trying to fence in so that you can find the perimeter. Okay, so that's perimeter, it's the distance around a figure. So with the problems that we're working with and the problems that you've done before, to find the perimeter, you're going to find the lengths of all the sides of the figure, and then you just add them up. Okay, so same story, but now notice instead of actual number lengths, we have expressions for lengths. The way that you do it will not change. Okay, so if they said find the perimeter of this figure, well, you'd have to know the lengths around, so we know the lengths of all of our sides, and so now all we have to do is add them up. Okay, so to find the perimeter, which you put a P for perimeter, you're going to take, and it doesn't really matter which side you start with because you're adding them. Okay, so I'm going to start with that one, have to take that plus the next side, so that would be 2x minus 1 plus my other side. Make sure that you have all the sides added up, and then you just have to simplify. And so normally with the problems that you've done before this, you would actually be able to simplify and get a number out of it. But for this one, you're just going to simplify the expression like how the other problems would simplify. Okay, so you start with your like terms. So my 3x, my 2x, and then my 5x are like terms. So I'm going to add those. So we got 3x plus 2x, which is 5x, and then take that plus 5x, you get 10x. And then we've got this 4 and then that negative 1 right there. So those are like terms. So I'm going to take 4 minus 1, which is 3. And so I get plus 3. Okay. And then that's everything. So that's as far as I can go because 10x and 3 are not like terms. And so that would be my perimeter. Okay. So that's with a problem like that. So now what if you had something like this? Well, let's say that this is a rectangle. If I had to do a problem like this, well, if it's a rectangle, I'm going to have to find these sides because, again, with perimeter, you have to have all of the lengths of your sides and then you add them up. And notice I don't have these two sides. So I have to know something about rectangles here. And one thing that we do know is that the opposite sides of a rectangle are equal in length. And so if that side has this length to it, then that side will be the same. So because this one is 2x squared, this one will also have a length of 2x squared. This one has a length of that, so this side will have that same length. So that one will be the exact same thing, okay? So now I have all my sides, and now I just have to add them up, okay? So to find the perimeter, and actually I'm gonna erase this other problem real quick. That way we have room. So to find the perimeter of this side, I have to add up all my sides. So we've got, and again, it doesn't matter which side you start with, just make sure you add them all up in there. So I've got 2x squared plus, and I usually just go around in a circle kind of so that I don't miss one. So that's my next one, plus my next side, which is 2x squared, plus my last side, which is 3x plus 2, okay? So from there, just like what we did with the other one, we're going to combine like terms and then simplify as much as we can. So I'm going to bring down my P. My 2x squared is a like term with this 2x squared because they have the same last name. So when I put those together, we've got 2 plus 2, which is 4. And then remember, when you combine like terms, the last name stays the way it is. And then we've got, well, we've got a 3x. And then we have a 3x right here. So those are like terms. So we got 3x plus 3x, which would be 6x. And then we have 2 plus 2, which is 4. And then make sure you didn't miss anything. And then make sure when you're done that you've combined everything that'll combine. And none of these are like terms, and so that is as far as I can go with my answer. Okay, so that's perimeter. You add up all the sides. Okay, now with area, it is different. These are two different things. So if they're asking you for the area, you're not gonna add up the sides. That's different, okay? Because what area is it's not a distance, it's actually the number of square units it takes to cover a figure. And so if I had like a coordinate plane that had actual squares on it, it showed you kind of how many square units it would be. One way to find the area is you could just take and count the number of square units it takes to cover that figure. But a lot of times in real life, we don't have that luxury of being able to count how many squares it takes to cover a figure. And so we're going to talk about the other way to find area, okay? So the other way to find area is you're going to find the area formula that fits that figure, and then you use that formula for it. So that's this part right here. You use the appropriate area formula for that figure, okay? So if we had a problem like this and it said find the area, the first thing I'm going to do is I'm going to look at what kind of figure is that, okay? Now I don't have anything marked here, so I'll have to tell you that this is supposed to be a rectangle. And so if that's a rectangle, then that means you're finding the area of a rectangle. So you actually have to remember something before you can do that. What is the area formula of a rectangle? Okay, so this would have been something that you've learned by now. The area formula of rectangle, you can think of it one of two ways. You can think of it as length times width, or a lot of times in this class, we'll talk about it as base times height. Okay, same thing. All right, so from there, we're gonna plug it in this formula. So your base would be the bottom of that figure, or the base of the figure is kind of a 90 degrees to the height of it, and we'll get into that later. Okay, so this would be your base, and since it's got two terms to it, I'm going to put it in parentheses, so it'd be 8x minus 5, that's my base, and then I have to multiply that times the height. And so this is the height, so I'm going to multiply it times this 3x squared. Okay, so from here, all I have to do is simplify. Now, in these problems that we've been doing where we have to multiply by a term, usually you're going to see that term up front. So if that bothers you, you can actually, because you're multiplying, you can actually move it to the front like this. So I'm going to move that 3x squared to the front, and then I'm going to write that next part behind it. That way I'm used to seeing it this way. And then you simplify. So because I have to multiply, that means you're distributing it to each term, okay? So when I distribute it, I would have 3x squared times 8x, so 3 times 8 is 24. X squared times x, remember when you multiply like bases, you add their exponents, and there's technically a little 1 right here. So 2 plus 1 would be 3. So when I take those times each other, it would be x to the 3rd power. And then the last thing, I have to take my 3x squared times my negative 5. So 3 times negative 5 is negative 15. And then my x squared doesn't have anything to multiply with, so remember it just comes down. And then these won't combine because they're not like terms. And so that would be the area, okay? And then we'll talk more about the units that you would put with them later.